One of the questions that I really wanted to ensure that I asked was the question about the subs. If each grouping of students received one less sub than there are people, are they truly getting an equal amount? And I really wanted to understand that because that's an easy pattern to see. 5 students, 4 sandwiches, 4 students, 3 sandwiches, then it must be equal. But if they really dive deeper into the problem and do either the division or do the common denominator strategy or any other strategy that they felt would help them at that moment and shared that strategy with another student, even if that student did another strategy, they'd be able to be successful in answering that question.
They're not receiving the same amount of sub because since the denominators are different, there's different parts of a whole.
Ah, okay. So now I'm hearing a different strategy completely. We've been talking about division, and now we're seeing a direct correlation, a direct connection with a common denominator. Explain this a little bit more, Crystal, this common denominator, and how is it related to this division?
Since they all have different denominators, they have a different total, and if you find common denominators, then all of the totals are gonna be the same, and then you're gonna see which one has more of the total or less than the total.
I think if you were to multiply them to find the common denominator, it'll be easier, and the denominator could be 40 if you wanted to compare them.
Okay, so now we have 2 different ways in comparing who got more or whether it was distributed equally. We have division, which was an operation we used, and we also used fractions with converting those denominators into like denominators. You have your hand up, Kayleigh?
For the second one, I got 8/10, and if you use a strategy that Crystal did, if you find equivalent fractions for 4/5, if you multiply that times 2, it'll give you 8/10, and you can convert that into a decimal.
The goal is with the groupings, they're allowed to think about what they're doing with the help of a peer who may understand it slightly better or a peer who may not understand it slightly better.
What does a 60 represent? Is it minutes or seconds?
Seconds.
That it takes to make no. 60 seconds equals
a minute.
equals a minute. So the numerator is gonna be
The seconds.
yeah. So it's seconds over the seconds that it equals to make 1 minute.
There was that I put 5, 6, and I used the rule 1 minute equals 60 seconds. Then I multiplied by 10, and I got 50 over 60, and I got my answer as 50 seconds.
Now I want to highlight 2 different strategies that were used here, okay, in order to obtain seconds. And this is where the conceptual knowledge of math really shines, okay, because a rule can only take you so far, okay, because what happens that day, you forget the rule. If you know how everything is connected, why it's connected, and what's related to each other, you can find ways of solving and persevering through that issue that you're having, that problem you're having, by finding a different route there. Math is all about different routes. Any route will get you there if it's a precise and correct route. Now over here, what I see is I saw division being taken to that correct route. Well, over here, what I saw was changing the denominator into what we know as the rules. As you grow older, the conceptual knowledge and the concepts that you're learning are just going to get more difficult. And that struggle really allows every person to know that there will be struggles and you need to persevere through them. You need to find a way, whether it's by yourself or whether it's with a partner. Either way, you're going to get to that output where you want to be.